All right, hey guys, lesson day 2. Now we're going to talk about what we call compound inequalities. It's when you put two inequalities together. Okay, a compound inequality is an inequality formed by joining two inequalities with the word and or the word or. Okay, we're going to talk about and inequalities today, and we're going to talk about or inequalities. Okay, if you make a statement and you say, I am going to do blank and blank, will you agree with me that the only way that is true is if you do them both? However, if you make a statement and say, I'm going to do A or I'm going to do B, then that statement is true if you do A or you do B. All you have to do is one or the other and it makes it true. You can do them both. It still makes it true because you said that you were either going to do A or B. You can do them both. Okay? So I put tick marks on my lines already. Now, I like my tick marks to be fairly symmetric, meaning evenly spaced. I went ahead and I used a ruler with centimeter and millimeter marks on it. Just me, I guess, but I would like you to do your best to make your tick marks evenly spaced. All right, let's go. So let's start with the and. A solution of a compound inequality involving and is any number that makes both, my pencil wasn't out, both inequalities true. Okay? So if we look at the first inequality, and we've done enough practice already yesterday with this, x is greater than 2. Well, I need to number my number line, correct? So I'll go 0, 1, 2, 3, 4, 5, 6, 7. Okay? Now, x is greater than 2 is going to be an open circle, and it's going to be everything that goes this way, right? We're going to make our arrow going that way. That is x is greater than 2. In this inequality, it says, and x can be less than or equal to 5. Okay, so 0, 1, 2, 3, 4, 5, 6, 7. I'll number the second one while I'm at it. Okay, now, x is greater than or equal to 5 is a closed circle. By the way, I didn't review. That's open. This is closed, right? So, closed circle on 5. We know that 5 is the solution. And then we need to find the values that are smaller than 5. 4 is smaller than 5. 4 is less than or equal to 5 is true. So this one goes this way, okay? And my arrow is over here. Okay, so what we are going to look for in ands is we're going to look for the overlap. I'm going to talk a lot about the overlap. It's important. So if you look at these two, and when we get down here to the rest of the homework, I don't draw two number lines, I draw one, but I will show you when we get down there. But I draw this, and I draw this, and I look for where they overlap. So 1 is not greater than 2. 1 is less than 2, so that's why it's not in this solution set. So 1 can't be in this solution set because it doesn't satisfy both. So what we know is that up to, but including all the way up to 2, those numbers all satisfy less than or equal to 5, but they don't satisfy x is greater than 2. So it starts just on the other side of 2, and it includes all these numbers because you see the squiggly is in between both, up to 5. And now to complete this inequality, I just shade that in. So the compound inequality for x is greater than 2 and x is less than or equal to 5 are all these values in here. You can plug 3 in here, and it makes them true. You can plug 4 in here and here for x, and it makes them true. Okay, one more thing. When we have an and inequality, we can write it as what we say sandwiched in between each other. Okay, so But there's one little trick that we have to learn. X is greater than 2. What we do is we take 2, which is on the left, and we take 5, which is on the right. And to write a single compound inequality for an and, I put 2 here, and I put 5 here, and I'm going to put X in the middle. Now, X is less than or equal to 5. That's already right there. But what you want to do is you want to look at this guy. Okay? The inequality opens towards the X and it points at the 2. So make it open towards the X and point at the 2. Now, one more thing really, really important that I want to tell you about writing compound inequalities as a sandwich. These inequalities must point in the same direction. Okay? They must. Notice how they're both pointing to the left. Okay, they're both pointing that way. That's important. All right, let's move on. Now, a solution of a compound inequality involving or is any number that makes either or either. You say either, I say either, whatever. It's an old ditty. Inequality true. So all I have to do is satisfy one of them. I can maybe the number satisfies both, but I only have to satisfy one. So let's graph y is less than or equal to -2, but we need to number our number line. Okay, so I'm not going to number them all. I'm going to go 0, 1, 2, 3, -1, -2, -3. So -3, -2, 1, -1, 0, 1, 2, 3. -3, -2, -1, 0, 1, 2, 3. There, we have them all numbered. And they're all from -3 to 3. Doesn't matter. As long as we have -2 and 1 in our number line. So let's look at y is less than or equal to -2. -2 is going to be a closed circle. Y is less than or equal to -2 is a closed circle. Okay, guys, I'm back. Sorry. One of the challenges of teaching from home. My dog sees a squirrel and he thinks he has to go chase it. All right, here we go. Okay, this is going to be a closed circle because this is less than or equal to. So I'm going to go to -2 and I'm going to put a closed circle because 2 is less than or equal to -2 is true. If variables on the left, inequality points to the left. So my inequality solution set's going to look like that. Y is greater than 1, open circle, to the right this time, okay? I am assuming you've done yesterday's homework and you've picked up on this. Variable on the left, number on the right, inequality pointing to the right, arrow goes to the right, open circle, okay? So how do we graph this one? There's no overlap. It doesn't have to overlap, it's an or. If it's an or, it does not have to overlap, okay? Ands overlap, no need to overlap in an or. Can an or overlap? Yes. If an or overlaps, that means we have infinite solutions, but we'll get to that later. So -2 gets closed circle because it's up here. 1 gets an open circle because it's right here. My arrow goes to the left and my arrow goes to the right. And that is graphed. All right. We're cruising. So now we have 4 more examples that we're going to work through. And I'm going to move a little bit quicker because I've done all the teaching. Now we're going to do the application. So these two, A and C, are ands. These two, B and C, are ors. Oh, you can't see B and C yet. It's down here. But this side is ors, this side is ands. Okay? So what I'm going to do is I'm going to solve this. Now, this is sandwiched already. So What you could do when you sandwich is you can just cover up the left side. And what would you do to solve this inequality? You would add 5 and add 5. But if I covered up that side, you would add 5 to this side. So here's what I'm trying to point out. And I'm trying to do it by observation first. When I have an and it's sandwiched, I start from the middle and I clean everything up and solve for r. But whatever I do to the middle, I have to do to both sides. So I added 5 here to move the 5. I have to add 5 to the right and I have to add 5 to the left. Okay? So now just clean it up. This is 1 and it's less than r and it's less than or equal to 4. I didn't flip any signs. Do you remember that rule from yesterday? That rule said if I multiplied or divide across an inequality by a negative number, then I flip. We will review that a bunch today. So this is my inequality. R is greater than 1 and R is less than or equal to 4. That's how you read this. You read the left side first. R is greater than 1 and R is less than or equal to 4. Okay, so we'll talk a little bit about scaling here. A lot of you like to have every single number in order, and that's fine. And it most always works, but it doesn't always work. In this case, it will. I'm just going to go 1, 2, 3, 4, 5, 6, 7. I put down 7 numbers. From 1 to 4 is 3 numbers. Well, okay, so 0, 1, 2, 3, 4, 5. Okay. Now I told you that I don't draw 3 number lines when I solve these. I draw 1. Let me show you how I go about doing this. I cover up the left side, if you will. Before I do that, let me just say that we can not sandwich it and we can write it as R is greater than 1 and R is less than or equal to 4. If this helps you to graph, then break the sandwich up and write it like this. So now if I graph R is greater than 1, it's going to be an open circle and it's greater than 1. It points to the right, so my arrow would look like that. Now if I graph this one, it's a closed circle at 4. So above the line, this is the way I was taught, and this is the way I've always taught it. I put a closed circle at 4 because 4 is equal to 4. 5 is not less than 4, so 5 is not in there, but it's pointing to the left. So it goes like this. And now what I was saying to you earlier when we were talking up here is that I do one number line, and this is what I told you I was going to show you, is I graph my 2 inequalities either above and below it or above and above it, like I've done here. And then what do I look for? I look for the overlap. You can see the overlap right here and right here. This is where the 2 inequalities overlap between my fingers, okay? You can see that it looks like one section between them. So all you do now is you come down to 1 and you make an open circle here, closed circle at 4, and then color it in between. That is what an and looks like, okay? I said a minute ago, if an or has overlap like this guy, then it's all solutions. For an and, if there's no overlap, then there's no solution. We'll get to those. Those are coming later. So here is my solution graphed. All right, B. B is an or. Now we're talking about an or. So I'm going to solve the left side first, okay? And the way I'm going to go about doing that is subtract 3 and subtract 3 from both sides, which leaves me with 4x is less than negative 8. Then I'm going to divide by 4 and divide by 4. So I end up with x and I end up with negative 2. Do I flip it? No, this is not negative, this is positive. So it stays the same. And I write or in the middle, and I do the other side. Okay? Minus 7, minus 7. Negative 2x is less than or equal to negative 6. Divide by negative 2, divide by negative 2. X, negative 6 is divided by negative 2 is 3. Aha, you might be yelling, flip it, and hopefully you are. I'm going to flip it. Why did I flip it? Flip, because I divided by a negative 2. Okay? So I flipped it. This guy now looks like this guy. Okay. So let's graph this guy. Now, I don't know how well you're getting along with this, but x is less than or equal to negative 2. If this is 0, here's 1, here's negative 2. Here's negative 3 if you want, and here's negative 1. Here's 1, 2, 3, 4. There's 3. This is going to be an open circle at 2, negative 2, and it's going to go this way. This is going to be a closed circle at 3, and it's going to go that way. Let me ask you a question. I didn't put a 1, a 2, or a 4 here. Do you think you understand just by looking at it that this is 4, and then comes 5, and then comes 6? Yes. Oh, I don't get real excited, but these are the 2 key points. But if you feel uncomfortable, then do this. But when we get to larger numbers, you're going to find out that it takes a little more. It would take a huge number line for big numbers. So we need to think smart, okay? 2 more examples. Let's move on this one a little bit quicker. This one's an and. So because it's an and, I'm going to work from the middle out, and I'm going to undo 3 times x plus 6, just like we've been doing in class. Multiply by 3, add 6. Subtract 6, divide by 3. Multiply by 3, add 6. So undo it by subtract 6 and divide by 3. Okay. Minus 6, minus 6, minus 6. Add down. Negative 15. 3x, 12. Negative 12. No, sorry, 12. Okay, now, I didn't multiply or divide, I subtracted. So these stay the same. Okay? Those stay the same. What do I do now? I divide by 3, I divide by 3, and I divide by 3. Negative 15 divided by 3 is negative 5. 12 divided by 3 is 4. 3 divided by 3 is 1. Do I flip this any signs? No, because these are positive values. Okay? Now, we can also write this as x is greater than or equal to negative 5, and I'm going to use that symbol for and, x is less than or equal to 4. Look, if you take the time to think about it, this is just right here. But this one, when you write it, you're just flipping everything over. Okay? You're just going to take it like this and flip it over. So the x goes over here, the negative 5 goes over here, and this guy flips over. It's not like multiplying or dividing. It's called the reflective property. Reflexive property. I'll get it right. Okay? Now, we have not finished. My bad. So I got negative 5 and I've got 4. If you do the math, there's 9 points between them. Watch. I'm going to put 0 here. I'm going to put negative 5 here. And I'm going to put 4 here. I'm only going to put 3 numbers. So if I graph this one, x is greater than or equal to negative 5. It's going to be a closed circle, and it's going to go that way. This one is going to be a closed circle, and it's going to go that way. How do I know all this? Well, because I've been doing my homework. X is on the left, numbers on the right. This points in the direction of the arrow, right here. X is on the left, numbers on the right, points in the direction of the arrow, right there. Okay, what do I look for? I look for overlap. Okay, look for overlap. So, final solution, closed circle, everything in between. I didn't have to do 10 numbers, okay? All right, now, last example for this side, then we'll go to the other side. It's an OR, okay? So, I'm just gonna work one side at a time. All right, because it's an OR. Okay, because it's an OR, we're gonna work one side at a time. Okay, minus 28, minus 28. F over 2 is less than negative 18. Okay, multiply by 2, multiply by 2. Thought there was something wrong with my numbers. Negative 28, take away 18 is negative 10. Okay, multiply by 2 both sides. That cancels the 2's. F is less than negative 20. Or, now we work the other side. Okay, divide by negative 9. F and 5. Okay. Less than or equal to, but I divided both sides by a negative, so I must flip. Okay? When I'm talking about flipping, remember, I'm talking about that. I flipped my inequality. Okay? So, F is greater than or equal to 5. Okay? Look at how big, far apart these numbers are. So, I'm going to put 0 here. If you are not comfortable just spacing out, go like this, 5, 10, 15, 20, okay, 5. You can put another one, there's 10, there's negative 15, okay, now you got scale. If you really need to mark everything. So, it's an OR. I don't need to look for overlap, so I'm just going to graph both of them on the number line right off the bat. If I look at the first half, it's an open circle at 20. So I make an open circle. It points to the left of negative 20, so guess what? It's going that way. Over here on the right, 5 is the important number, and it's greater than or equal to, so it gets closed circle. And my variable's on the left, and it points right. Okay, now I'm not talking today about checking inequalities because I'm assuming you've learned that, but if you have to, plug in 0. Is 0 greater than or equal to negative 5? No, it's not. So 0 is not in the solution set. That's why it's not colored pink. All right, we'll do the second half in the second part of our video.